Hello friends, my name is Shivam from DevOps Schools and I will help you to enable your learning process in various technologies of DevOps, artificial intelligence, machine learning, big data and many more. This is our initiative to help you by sharing multiple tutorials and videos. And if you want any specific tutorials on any particular topic, then please do comment in the below comment section and I will help you with it. Also, please subscribe to our premium services on YouTube, which will give you access to more content and videos to enhance your knowledge about all these topics. Also, if you want me to help you with regards to the online trainings and classroom sessions by our qualified trainers, then please do write me at contact@devopsschool.com. Thank you.
Are you guys done with this? Just create this particular topology, how the things are connected and IP addressing. Rest of the things which you can do it later on. Because this will give an idea how we can do the practice. You can build your own topology and you can do it as well. Correct? So this is called as static routing, where everything, whatever best routes are there, whatever alternate routes are there, everything needs to be configured by the administrator. If any route goes down and if your administrator don't know, so your packet will fail. So you have to configure the alternate path for that. If it is not already configured, you have to configure now. So this is a complete manual process, very fast, very effective, because your route is there already, but it is something which is only created for smaller network, not for bigger networks. So if you have 5-6 routers, I can accept you can manage to have some sort of manual settings over there. But if you are going for a very huge network, then definitely it is not the good idea to go for it. Correct? Now this is what we can call it as static routing. Now we are not using this router anymore. Okay, in production environment, remember that in production environment, it is something which we are using, which is called as default routing, not the static routing. Correct? Now, before we move to the default routing, there is a concept called as routing lookup. There is a concept called as routing lookup. Okay. First of all, whenever, let's say this computer, how router can go for it, how router can find out and router can forward your packet to another network. Okay? This is nothing but a router lookup. So what exactly happened when this computer wants to communicate to this computer? Correct? So whenever this computer try to send something, what is my source IP address? This is my source. What is my destination IP address? This is my destination IP address. And this packet or this data is actually moved to the switch. Correct? Now what switch can do? Okay. Switch says, I don't know your IP address. I know your MAC address. Correct? Now, in order to put the MAC address over here, I told you, if you are in the same network, means this particular entire local address, they do know their MAC address because of ARP. But is he going to know the MAC address of this computer? Is it a part of this network? No, this is not the part of my network. I don't find any MAC address of this particular IP address because this IP address is not my network. So ultimately, this particular computer already makes sure that this is not the part of my computer. So I should put the MAC address to the next gateway. That means your switch will not bother about it. He will directly put the MAC address of this, which is nothing but a gateway MAC address. When the switch receive this packet, he will see, Okay, what is my destination MAC address? Destination MAC address is the port where my router is connected. He said, okay, I want to forward this request to the router. Correct? When the router receive this request, what router is going to see now? Router is going to see the destination IP address. Now he do not concerned about your particular MAC address. He works on IP address, which is a logical address. Then he will go to his routing table to find out, okay, this is the destination. Could you please provide me the best route to reach to this particular destination? So actually he's doing some query to the routing table. So once he has done the query to the routing table, what he want to do, he want to find out the best path. That means the closest path, fastest path in order to actually reach to the destination. Correct? So in that particular condition, if your entry is not available in a routing table, router got a request, he is actually try to forward that request to another network, but before he do that, he is going to check the routing table. Correct? And if that entry is not available in that routing table, then by default your router will discard that request and send destination host unreachable. Correct? If there is an entry in the routing table, then he will forward that particular packet to that interface. Okay, that interface which needs to get out, which needs to take that packet out, and he will start their journey up to the destination. Correct? So this is very important concept called as routing lookup. Correct? This process is called as routing lookup process, where your router will find out the best destination. With the help of routing table, he would be able to find out which interface he need to get out from this router to proceed with his journey. Correct? So understand, every routing protocol which you are using, every routing methodology which you are using, what is the three concept you need to remember? You need to understand whether that particular route which you want to go for a destination, is it available in that particular table or not. Correct? So this is called as static routing mechanism, which is only usable, or which you can use inside only small organization. You cannot use it in a bigger organization at all. Correct? I hope it is clear that what is a routing. Now what I did, I created two different networks. Now both the networks are able to talk with each other when they are totally different network at all, but they are able to talk with each other with the help of static routing method. Correct? So this was the first routing method which we are going to discuss. Okay, do you have any doubts in the static routing method? This is little bit complex to understand sometime, but when we further talk about dynamic routing method, it's very much easy and very much simple. So today everyone should do practical. We do have good enough time for today because we do not need to cover a lot of ground. So that's why I am giving you 10 minutes for creating that particular topology. Correct? So let's take a 10 minutes of break, and we will proceed with default routing method. After, you can rather take 15 minutes of break.
Hello, sir.
Yes,
Sir, can you please show the connection between the router and the router?
this one, this is called as
Yes,
serial
sir.
connection. I will show you one more time. Okay, so serial connection should be connected like this. Look at my screen carefully. Let's say I have take this router, I have take this router, correct? Now, if I go to this router, I need to add the module called as serial interface. By default in the simulation, they have not added it. So what I need to do it, click on this. Okay, now currently this is a back panel of your particular router. There is a power button over here. Remember this. Okay, it's very small. If I click on it, your router is turned off. Now I would like to put the modules. I told you every router is modular now. I can put the port. They are trying to emulate the same thing with the help of simulator. The module which we required is called as HWIC. Okay, this is how the module looks like. Drag it and drop it over here. Okay, don't forget to turn on your router again and confirm it by clicking on CLI. You should be able to see this one, correct? Repeat the same process for this router as well. Whatever router you purchase, whatever router you are going to take for simulation, you have to follow the same process. I can turn it off. HWIC is the module. Put it over here, turn it on, confirm it is turning on. That's great. Close it. Now you are able to connect the two routers together, correct, with the help of serial interface. Now in real life, there is a serial port. You are not supposed to add the module. By default, you will be getting one couple. There are two ports. Couple of ports are available from smart serial interfaces. So you can already use that. Is that clear?
Yes, sir. Clear. Thank you.
Okay. So create this particular topology. Okay. So I hope the static routing is I think it is clear that everything has to be done manually and every best route has to be configured by administrator manually. So it is a complete manual process which we are going to use it. And plus very important information which we required is we would like to have destination network ID. It is something which is very, very important, which we required. In static routing, I need to know the destination network ID. Correct? Now there is another type of routing. We can call it as default routing. Okay. Now the mechanism is same. A router do have a best route. Once the request come, if the best route is available or route is available, I will forward that packet to that specific destination and I will make sure that where that particular packet should go out. So that is exactly the same. There is no change in that. Correct? However, default routing is actually used for internet and end locations. So the first reason why we require default routing because of internet connectivity, and second one is called as if you have end locations. Okay, end locations I will tell you what. Okay, now let's take about the first thing that it is used for internet. Now what is a thumb rule of the router? If any request comes from here to here, what router will do? Router will say, first give me the particular default, sorry, first give me the best route to your destination.
Hey viewers, trying to get into DevSecOps? Enroll for our DevSecOps certified professional programs and earn the certification that shows you are fit for these technical roles and requirements. Contact info is mentioned in the video sidebars and in the description box. Book your seats for the upcoming batches now.
Correct. I should have the destination mentioned in my route tables. If I find out the destination in my route table, then only I will forward your request to next hop or the next router through their exit. This is a thumb rule. Correct. Now in static routing, what we have seen, we have already mentioned that destination is there. We provide the destination. Based on that destination, my router created some route table. Correct. Now that route table contain all the destination which I want to go. So that's the reason any request coming from my computer, it goes to router. He check the route tables, appropriate route is there. He will forward that request out, and he will also make sure that which interface he want to take that request out. Correct. But what if this computer want to go to yahoo.com? Correct. Yahoo.com, I need to go for it. Now, whether Yahoo is available over in this local area connection? No. That means where that request will go? Request will forward it into the router. Once again, what is the thumb rule of the router? He would like to go to yahoo.com. Correct? Do you have any route set for yahoo.com in a route table? If it is not, then this particular request would be discarded. Somebody want to go to google.com. Now there in your organization, there are many people who is accessing the internet. So each and every time, if I would like to create a route inside your router, then it is not technically possible. I can do the routing for my internal organization, but if you are talking about internet as well, means there are millions of websites. So should I place all those websites in my routing table? Plus, how do I come to know that what is their destination? Does Yahoo is going to provide me their internal IP address? In static, what I require, network ID of your local where I want to connect it, and the entry point where I can come in. Now, does Yahoo is going to provide that? Correct. Now, in order to get the internet connectivity where I don't know the destination, at all, in that particular condition, I'm using default routing mechanism. I don't know the destination. I don't know the destination subnet mask. I only know the next hop. Now, my next hop is nothing but my ISP, to be honest. So ISP will take care of it. So in default routing, any request come to yahoo.com, correct? It will go to the router. Router will read the route table, and he couldn't find the route table in the router itself. He said, I don't know where is this destination. So rather discarding that, if I have a default routing set, he will say, I don't know. Maybe my ISP router can know. Maybe this is my ISP router. So rather discarding that request, he will set that request to next router. He can also do the same thing till the point where somebody over the internet will find out that information. Correct? Now this is called as default routing. Now default routing is mandatory if you want to use your internet connection in local area connection with the routing mechanism. Otherwise, router is pretty strict. I do not find anything in a routing table, discard. But if I do not find any routing table, do not discard it. Let forward that request to the next hop and let's see whether he is able to find out. Correct? So this is only possible if you have set up the default routing mechanism where I don't know the destination, I don't know the destination mask, anything. Correct? So that is called as default routing. If I would like to go for any kind of internet connectivity I require this type of routing to be set up. This is very, very important routing mechanism. Correct? Now there is another option called as end location. What we can call it as end location. Now I will give you one more example where you can use default routing. Okay, let's say I will take a couple of routers over here. Okay, let's see, I do have situation like this. Okay, if I have situation like this, I will take one more over here. Okay, so if my topology is like this and all the three devices are actually connected, in this format, correct? Now you can imagine, okay, this particular topology. Now this will be this router, let's say this is router A, okay, and this is also router B, correct? These two points would be considered as a end location, correct? Now what is a default routing rule says, if you don't know the destination, I will forward your request to the next hop. Don't worry about that. Do not discard that request. Let's go to the next router and let's find out whether he has it or not. This is a default rule. Now in this particular type of scenarios, if this is my router, if he want to contact any router over here in this topology, he need to contact to this router B every time, isn't it? Correct. This is router B. Let's say this is router C. This is router D. Correct. So every time if I would like to go from A to D, what should I do? I need to contact this B. Correct. This is not a B. Give some other name. Okay. If I would like to contact this router, I need to contact this router first, and then only he will forward my request. Correct. Now this condition is called as end location, where rather creating a static routing, because if I want to create static routing, I need to create the route for this plus alternate route, everything, correct? So rather creating huge static routing, can I create a default routing? Yes, because this is anyhow, this router is not going to talk with any router, he's only going to forward the request to the B. So in such kind of scenarios where you are having end location, that means any given point of time, you know that this end location is going to contact only with this router and this will take care of it. In such cases, you can use default routing, correct? Now this is a very, very rare case you can get it, but end location could be one of the best possible way, that rather creating multiple static routes, you can create a default route, correct? This is a very, very simplified way, but 99% in your organization, there is a default routing setup. For what? Internet connectivity. Why it is like that? Because router mechanism says, if I do have an entry in the route, then only I will forward your request to go outside. If I do not have entry, I would discard it, correct? But I don't want that particular entry to be discarded. Let him forward it to the next router, whether it is a ISP router, and let him resolve it. You do not discard it, correct? So this is how we can get the internet connection available in our organization through the router. Now, how I'm going to do in the lab setup? What is a possible way we can do it? Now look at this case very carefully. What I will do, let's say this is yahoo.com server. Okay, which is available over the internet. Now this is my ISP. This is my ISP router. What I will create a static routing from here to here. That means this particular guy would be able to know this particular network with static routing. Correct? Because this is a ISP. This is my ISP. And from here to here, I would go for default routing. What is that? Default routing. I don't know this destination at all. I don't know this destination at all. Still, I'm able to go here and I'm able to get a reply from here. Now the reply is coming from static, but my request is going through default routing. Correct? So let's see and configure that and see how default routing can be configured. Correct? So first of all, go to this router and let's configure the interface. Okay, what is the name of this interface? Gigabyte 01, sorry, 00. This interface would be 030. Okay, so if I go here, CLI, I would say no. I would say enable conf t. I would say interface gigabyte 0/0. Okay, IP address 192.168.6.1, 255.255.255.0. Enter. No shut. Okay, so my interface is configured. Now let's go to the serial interface. Serial interface is 030. Okay. Now here I'm using the IP address scheme for this is 20.0.0.2. So 100% here we can use 20.0.0.1. So here we can use 20.0.0.1. Correct. So this is the serial interface 03. So I will exit out of this interface. Oh, sorry, enable conf t. Okay, interface serial 030. Okay, IP address 20.0.0.1. Subnet mask is 255.0.0.0. Okay, no shut. Okay, now this is done. Now let's go back to this command line. Enable conf t interface serial 030. IP address would be IP address 20.0.0.2. Subnet mask would be 255.255.0.0. Press enter. Correct. I would say no shut. After that, I will go to this is 100% gigabyte interface, but I would confirm it gigabyte 0/0. So I would say interface gigabyte 0/0. I would say IP address. Now IP address would be, what is this IP? 200.0.0.1. Okay, 200.0.0.1. IP address would be 200.0.0.1. It means it's a class C IP address.
Hey viewers, Our Master in DevOps engineering program can help you to hone the skills necessary to succeed in high-level DevOps positions. So, what are you waiting for? Enroll now and earn certification that show you are keeping pace with today's technical roles and requirements. Contact info is mentioned in the video sidebars and in the description box. Book your seats for the upcoming batches now.
Okay. So what I'm going to do, from here to here, I will configure the static, but from here to here, I will configure the default. So this one don't know anything about 200, but still he would forward the request to this particular router in order to reach to destination. Okay. So if I go to this router, I will configure the static route. I will say IP route. I want to reach 192.168.6.0 network, whose subnet mask is 255.255.255.0, and my entry point would be 10T 20.0.0.1. Okay, so this I have configured. Correct. Now let's configure this as a default routing. Now understand how we can configure the default routing. What are the different ways to do it? So where I want to reach it, I don't know. I only know the entry point. This is my ISP entry point. That's it. I really don't know anything about my destination. This destination is not known to me. I don't know anything about it. I know this is the IP address of the router. This interface is nothing but the IP address of this particular ISP. That is means where I can forward the request for. That's it. Correct. So what I will do, I will say IP route. Okay. Do I know the IP address of the destination network ID? No. Do I know the subnet mask? No. Do I know the ISP address? Yes. That is the only address I know. Correct. Press enter. Correct. Now, if you look at the IP tables, show IP route, you will see there is a default route set. That means whenever any request come to this router where you don't know where is my destination, it is simply go to the next hop. It's a clear-cut meaning. Correct. So am I able to contact to this server? Now, do this particular router know anything about 200? No. I really don't know anything about it. Okay. I just created a static routing to come here just to emulate the internet connection. That's it. Correct. So let's go to this computer and try to ping this server. I would say IP config. Enter. I would say ping 200.0.0.11. I'm getting reply, so I'm able to reach. Now try trace RT 200.0.0. Now you can see the request goes to the router interface. Then it is forwarded into next hop. Next hop is nothing but it is his direct connection. So he is able to go to the destination. Correct. Now this is something we can call it as default routing methodology, which we can normally use for internet connectivity, because according to the rule of routing, if I couldn't find out anything into the routing table, by default router will discard my connection. I cannot create the route for each and every website on my router, because first of all, there are millions of websites which people can access. Second important information would be, I don't know the destination information about that particular website. even they will not be able to provide any information about that. Then what is the solution? Solution is default routing, where if I don't know the destination, the strategy is very clear. If I don't know anything, let forward it to another one, he might know about it. Correct? So this mechanism is called as default routing, where we can use this particular mechanism in order to use for the internet connectivity. Okay, now you can take this topology as well and understand how I did this particular thing. I will give you 5 minutes in order to create this particular topology. So take your 5 minutes and create this particular topology. So if you would like to do the practice, you can do that. Okay, the topology is very, very important. Okay, now we will talk about another type of routing method. It's called as dynamic routing. Now this is widely used. Okay, this is called as dynamic. Now this is very, very important because here majority of things are done automatically. First of all, very important thing here, I don't need destination network. I really don't need any destination network ID. In dynamic routing, I only know what I am connected with. That's it. Now in dynamic routing, what are the best route are available? Those will be learned through advertisement. Correct. Now this is very interesting in case of dynamic routing. I will tell you. I will explain you with the help of topology what dynamic routing can be done. Okay. So if I close all these things, let's take this example. Okay. Now what in case of dynamic routing, what exactly I'm going to do with? Now dynamic routing, in that dynamic routing, first of all, I really don't bother about what destination which I really don't know anything about that destination. I agree, that's fine. If you don't know about any destination, in dynamic routing, there is a method that I will get all the information about destination. Listen how. Now let's say this is the scenario which we are working on it, and rather creating a static routing, which is a manual process, I have created a dynamic routing. In dynamic routing, what I need to tell how to configure that dynamic routing. In dynamic routing, I'm not supposed to know about this network at all. I just need to expose what network I have connected with. If I see this router, it is connected to 172.16.0.0 network. It is also connected to the 10.0.0.0 network. I just tell I can configure the dynamic routing by saying this. I'm connected with 172.16.0.0 and I'm connected with 10.0.0.0. That's it. I'm only exposing what is connected to me. I do not bother what is this local IP address, what is this IP address. I really don't need to bother about it. What I have, that is the only thing I need to bother about. So in dynamic routing, if I don't know the destination, that's fine. I don't care about it. I only care about what is connected to me. Correct? So what in dynamic routing we are doing, we are simply telling that I am connected with this network ID and I have this network ID connected. That's it. That is my own information. But you are going to say, then how come he will come to know these destination? What are the best path? I will tell you. Now all the routing table which he's going to learn, I need to find out the best path to reach from destination, from the source to the destination. All this best path, I need to learn it. In static routing, every particular path which I want to tell you, that particular path needs to be provided by administrator. But here, I don't need to wait for that. I need all the information about the best route. I am getting that information from the other routers. Correct? In dynamic routing protocols, what exactly happened? If all dynamic routing protocols are configured in this topology, what this router will do? A router will start creating advertisement. Now, what advertisement he's going to create? He's going to create the advertisement of their best route available with him. To be honest, every router which is the part of this topology, and if it is dynamically connected, every router will start sharing their own routing table with each other. Correct? So if I have all the list of the best route available with me, I will share it with my neighbors. I will give it to all the routers which is in the part of my topology. In static routing, we are not supposed to do this. We're supposed to know what is the destination. We are supposed to create the complete path of the routing manually. Here, am I need to know the destination? No. He just say, just provide me what you have connected with. Okay. So whatever you have connected with, after some time, your router himself will get all the information about the routes from others. Even your router is also going to share your routing information to others. Now, this is the basic feature of dynamic routing, correct? Now, dynamic routing will learn all the best route by exchanging the information with each other, correct? I do not require to know anything about my destination at all. I will get all the information about the best route which I shared to others, and other will also share their information to me. So this exchange, okay, this is something very very important, that if this particular router do have the list of the best route, this router do have the list of the best route, this router do have a list of the best route in their routing tables. So they will share the exchange the routing table information with each other. I really don't need to bother about to build any destination. I would be able to know the destination without configuring it. I will automatically get all the routes, because in dynamic routing, all the router will exchange their route table to each other. This is the beauty of it. In static routing, we have to configure each and every route manually. In dynamic, I told you, you just need to tell, I'm connected with this, I do have this. That's it, your own information. The rest of the information will be shared by other routers, and you also sharing your information to other routers. This is the behavior. In any case, in any case, if your best route goes down, okay, if you can see in my router, there are multiple best route, and there is this, I want to communicate from here to here, and this is my best route for the time being, correct? And if I come to know that this best route is goes down, correct? In static routing, if I do not have any alternate route setup, my network is down, correct? But in dynamic routing, it will choose the new alternate route to reach to the destination dynamically, correct? Now this is very important. In static routing, I need to make sure that every route has to be manually present. In dynamic routing, I do not bother about it. My router itself find out the best alternate possible route if the best route is down. If on his best route is down, he will try to find out maybe there is another router like this. It could be. So if this goes down, he will say, I do have another one. Correct? So this is automatically happened in your dynamic routing mechanism. Remember that in static, it won't happen like that. Correct? So dynamic routing is the very appropriate solution for bigger environments, because here router is exchanging the information with each other, correct? Whatever best route are available, router is sharing their best route with each other.
Hey viewers, are you looking for formal training on SRE practices? Take our SRE program. This course will teach you how to successfully implement site reliability engineering in the modern day 24/7 services. Kickstart your SRE training today. Contact info is mentioned in the video sidebars and in the description box. Book your seats for the upcoming batches now.
Correct? They are doing advertisement. If anything goes wrong, any network is shut down, your router is shut down, link is down, anything happened gone bad, and because of that, your entire best route which you have selected from source to the destination, it goes down. Router will automatically find out the alternate path, correct? Any changes is happen into the network topology, router will share that updates across the all the routers into the network. So dynamic routing, it's the best choice for very large organization where people do have hundred of routers and connected together, correct? So understand, in dynamic routing, I just need to expose what are the network connected with my router. I do not bother about what you are connected, what he's connected. I really don't need to bother about anything at all. I only need to bother about what I have connected. That's it. Rest of the all the information automatically comes to me from my other neighbor routers, who is actually sharing all his information to me. I am also sharing my information to him. This is how we can build our own routing tables, correct? So this is what in dynamic routing, what it happens, correct? Now in dynamic routing, there are three different categories. Okay, in dynamic routing, there the first category called as distance vector. Distance vector dynamic protocol, correct? There is a link state routing protocol, and there is a third one called as hybrid. Correct? These are the three type of protocol which is actually available in dynamic routing. Correct? Now every type of protocol do have their own features and they are working on a different mechanism. Okay, so let's take about distance vector first. Okay, so if I come to distance vector, okay, rather I will show it on a topology only. That is the best option. Okay, so we are going to think about first distance vector protocol, and let's understand what distance vector protocol do. Okay, and distance vector, now this is a dynamic routing protocol, but it comes under distance vector. Now this type of protocols actually work with an algorithm called as Bellman-Ford algorithm. Okay, they are using Bellman-Ford algorithm in order to do that. They are getting periodic updates. That means I told you that every router will send all his information across the network periodically, correct? Because I need to update each and every router in my network with latest information. Now, latest information for what? The latest information about the routes which are available with me, correct? So this is called as distance vector. They are doing periodic update. Okay, now I told you that they will share full routing tables. I told you that they are sending their own entire routing table information, which is actually shared with each other. Now they work, this is called as classful routing protocol. Okay, now classful routing protocol, we know that technically speaking, these protocols are actually does not support subnetting. Okay, because majority when the exchange of routing is happened, route table is happened actually, this type of category of the protocol won't be able to exchange the subnet information. If I have a subnet information, which may be a subnetting kind of a thing, this router or this type of protocols actually shares the information, but they will share only the best route. They won't be able to share the best route along with their subnet mask. So subnet mask information won't be transferred in such kind of protocols. Now I'm talking about in case of updates. So by default, whatever updates which are coming to the router, they are also going to choose their own mechanism to define their own subnet mask. So it has to be standard, correct? So that's why it is a classful particular protocol, classful routing protocol. Update the, sorry, fifth point, update the routers with routing information in a broadcasting fashion. Okay, this is very interesting. I said they are going to exchange the information with each other. Now, when they are exchanging the information, they are actually sending the broadcasting message across the network. Now, there are certain protocols who actually work in a different way. We will discuss further, but in distance vector only, there are certain protocols called as RIP version 2 or next generation RIP actually work on a different mechanism. Okay, but RIP version 1 actually doing the broadcasting across the network to learn everything about their routing table information, correct? After that, what are the supported protocol? The supported protocol is RIP version 2, IGRP. These are the type of protocol which comes under the category called as distance vector. Correct? Now, IGRP is was the proprietary protocol and it was designed by Cisco. Correct? But currently we are not using RIP at all. Sorry, IGRP and RIP both are not we are using for production, correct? Because of their limitations, and because of that limitation we won't be able to use it. We will see RIP version 2, IGRP we are not going to see it, but RIP version 2 we are going to see that, correct? Now there is a different type of routing protocol or category called as link state routing protocol. The dynamic, there is one more category called as link state. Okay. Now in link state routing protocol, it works on Dijkstra algorithm. Okay. It works on Dijkstra algorithm. Okay. Incremental update would be happen. Okay. Only missing routes are exchanged. Okay. And classless routing support means subnet mask would be carried while transferring your particular route information. So classless routing protocol. Okay. Difficult to configure sometime because more overhead is required. There are many complex things are actually running, but you can say OSPF and intermediate system ISIS, who actually comes under the pure link state protocol, correct? This is interesting. So distance vector working on different algorithm, they are doing the periodic update. Here incremental update is happening. That means update is not happening periodically. It will wait for some time. If any changes are happened, only those changes can be replicated to each other, correct? If you are missing only some route, now they are not going to exchange all the routing tables to each other. They will only exchange the information which is missing in you. They will not be able to exchange the information across the network. They are actually doing multicasting, correct? Majorly they are doing multicasting. So the fourth point would be they will be doing multicasting. So this is little bit a very good category where people are actually using this type of protocol with their very huge networks required. So it works on Dijkstra algorithm. Incremental update means any updates are triggered that only time the update are exchanged. They are not exchanging the entire set of routing table. They only exchange the information which you are missing. If you are missing two routes, he only inform you about two routes. Other than that, they are not going to provide any information at all. Correct? So this is a link state routing protocol. Now there are some mechanism who actually work in link state. When we discuss OSPF, then we will discuss about link state as well. Correct? Now the next category would be an hybrid protocol. Now this is very powerful. Okay, this is called as hybrid protocol. Okay, he will do the same thing like link state. He will do the periodic update. Okay, he will do multicasting. He will actually doing the classless, correct? The important thing is it works on dual algorithm. worked on dual algorithm. EIGRP is the protocol who is actually a hybrid protocol. It was a proprietary protocol from Cisco actually, but nowadays it is open source that anybody can use that particular protocol in their router. But these are the three type of dynamic protocols which are available inside our particular network. Now it's up to you which routing protocol you want to use it based on your requirement. Correct? Now we will slowly see how we can configure RIP. Correct? Now before we configure RIP, we will create a small topology over here. Now we already created topology like this. Okay. I would like to add one more router into this. Okay, just a moment. So we will add that router. Okay, let me drink water, just a moment.
Thanks for watching. Want to study further? Join our training programs today.